Are we ready to go? Okay. Any questions from last time? No questions. You should ask. Okay, so where were we last time before I start this? We were, this is the result that we had derived last time. And I think I was saying something. Okay, anyhow. So, if you recall, I said that to find the slope of a function at a point, I will take the difference of the function, the value of the function at some neighboring point to the right at xa plus h, where h is positive, with the value of function at x, and then divide by h and take the limit h going to 0. Okay, so we said that the derivative of this function f of x, okay, which is also the slope of this function at any point x. Remember, by the way, I'm writing this as d over dx as one symbol. You should see it as one symbol. And when that symbol is written in front of f of x, it means that you take this. And I told you at this, up to now, I'm a little inaccurate in giving this definition. Or rather, same thing, okay? Okay, limit h goes to 0. So up to now I said, okay, I don't like it. So I said if you have a function and you want to know the derivative here at this value of x, then you take this value and then you take that value and take the difference, right? That thing. But this h is always, x plus h is to the right. Okay, this looks okay, but let's see where the problem will come. And there's a reason why I wanted a definition. I didn't give you the right definition so that you can appreciate why the definition is the way it is. Okay, so let's see, let's take example of a function you know this function mod of x? No? So f of x is equal to mod of x. So I'll just plot mod of x for you. So mod of x is here. Okay. Okay. And then, so this is a little sad. Okay, it's not touching origin, but I hope you understand. So this is x and this is mod of x. Okay. You see here at any point, let's say you take some value here, take some value of x here. The slope is defined. The slope, I mean, you follow this procedure and you get the slope here. Okay, meaning you are coming from the right, you assign a value, it's fine. Here again you can find the value and it will be the same value as you got here because the slope is going to be m. Okay, now when you come to this point, origin, I take this point x is equal to 0, okay, and I use that procedure where h is positive. You remember here I said h is positive. So you are going to 0 from positive values of h from the right side. Now if you do that, so let's take x here and then you are take a neighboring point x plus h and you come this way, you will find a value of slope. Okay, you'll get some value of slope. What will that be? That will be the same value you got here, or you got there, right? So you get that same value here. But when you look at this, do you really think there is any slope defined here? Right? Can you draw a tangent to this? If you look from this side, it looks like the slope is just the negative of that. Okay? So you see, that definition that I have given, that you come from that side, or if I had made a different definition that you always come from that side, there will be a problem at this place. It will appear as if it is meaningful to assign a value to the slope at that point. But clearly you see, just by looking at the curve, it makes no sense. So what we should do? We should do the following. We should not put that constraint. If the limit of this thing, when you come to that point x from right or from left, they are equal, then I will say I assign a value to the slope, or I assign a value to the derivative. Right? Do you understand? So we don't want just that restriction, so we'll remove that restriction. Now here h goes to 0 and h can take any value. It can take positive values, negative values, whatever. So that was the thing which was missing, and you understand the reason here. Okay? So the thing is this. We say that the function that at x so we will say the function f of x, okay, it's better to read as the function f, but it has become conventional to write x here. Okay, the function f has a derivative at x if this limit exists it's moving again. If this limit exists, irrespective of this h, or you could say if limit coming from that side and that side they exist, first thing is exist, and they should be equal. Okay? Then we say that the derivative exists. Okay? Is that okay? If derivative at x exists, then we say the function is differentiable at that point. Okay, if the derivative exists, then the function is differentiable at that point. Is that okay? Any problem here? It might be that the derivative does not exist. Okay, for example, look at this one. I don't know why I'm touching both hands, but it looks cool. You could have a function like this. Something changed, right? It could not have been here. Anyway. This is very helpful. Suppose okay, sorry for this is not good. Okay, now it's better. Suppose we take that point x, okay, and okay, this is not, I'm just I'm drawing a vertical line at this value of x, and suppose our function looks like this. Okay. No. Suppose our function looks like this. Why it didn't change the color?
So you're using different side.
Ah, correct. Very good. So it is going towards this. So this curve is going to meet this vertical line at infinity. It's going towards that. Okay. So it becomes vertical. Eventually, this becomes vertical. Okay. And suppose from that side, it is this. Now you see at this value of x, the slope from the left hand side, if you just go from the left hand side, if you take this limit, h going to 0 with h taking negative values, then it will be infinite. It will not have any finite number. So you'll say slope is not defined at that point if you're coming from the left hand side. But from the right hand side, it will be 0. Okay? So one has to be still a little careful, because when I'm saying here, I mean, see, the function will, let's say this point is not included. Okay? This point, so at this point, or other way around, we could do other way around also. Let's do it other way around. So here, at x, the function has this value, not infinity. You understand, right? Function has to have only one value at any given point of x. It cannot have multiple values. So at this value of x, this is the value of the function, and at any neighboring point on the left, it is given by this curve. Okay? So you see that if you take that limit, from this side you will get this slope of this point. But from that side, even that you cannot take. Because what will it be? F of x, at this point f of x will be this, and what is f of x plus h when h is to the left? It's infinity. Okay, so you see the slope will not be defined. Okay, so I hope now you understand why this definition is there. Good, so we can now move to next page. Okay, I'll give you one exercise which you can do using what has been taught to you already. So homework, using the definition of the derivative, find the derivative of fx where f of, like this, where f of x is equal to a constant c plus x square. B, f of x is equal to x plus x cube. Okay, and you should do it. What happened? Just say it.
When in the question, find.
Find.
Right.
Okay. Is that okay? So do it the way you have done. So you have to take the entire function, take it at x plus h, subtract it, take the limit. Now I'll go and prove a rule that will be very useful for doing such problems. Okay, and the rule is the following. Rule number 1. Okay, we call it rule, but it's, you can think of it as a theorem. I'm going to prove it. Okay, it's not some made up rule. The rule is this: if you have a function which is a sum of two functions, okay, and you take the derivative of it, then the result is just the sum of the two derivatives. Okay, I'll show the proof of this in a minute. Actually, it's obvious. But before I tell something about the rule, argue that this is correct, let's use this. So you do this homework the usual way, the way we have been doing before, but now let's use this rule which says take the derivatives of them individually and add up. What's the derivative of C? Constant? 1. Why are you making gestures? You just say it. What's the derivative of constant? What's the slope of a constant? 0. You're saying 1. Okay. What's the derivative of this? 2x. Very good. So the result will be, for this the answer should come out to be f prime of x. So sometimes I'll write d over dx, sometimes I'll write f prime. Okay. F prime of x is equal to 2x. And for this the answer should be, so I'm taking derivative of this plus derivative of that. What's the derivative of this?
1.
And for the other one?
3x squared.
3x square, not cube. Okay. But do it the way I have told you earlier. It will give you some practice. Now let's see this one, the proof of this. See, d over dx of this is just the limit of that limit which we make. Okay. But the sum of limits, limit of a sum is sum of limits. And from that you will get this. Shall I leave it as an exercise? All you need to do is, if you are taking limit x going to some x naught of some function fx plus some another function gx, this is just limit x goes to x naught f of x plus limit g of x goes to x naught. Is this obvious that this will work out? Okay. So I will leave it as an exercise. So rule 1 is an exercise. Homework. Is that okay? I will so let's take one example. Oh my goodness. Okay, some examples. I'll give you 2 examples. Let's say you tell me the derivative of, so find f prime of x. Okay, that's the first derivative. So where f of x is equal to okay, let me give you a polynomial. So some constant a naught plus another constant a1 x plus another constant a2 x square plus so on and so forth a n x n, where n is some integer. Okay, it's a polynomial given to you. What's the derivative of it? So what's f prime of x? So we will just take the derivatives of individual terms and sum up, right? That's the rule you have. See, if this works for sum of 2 functions, then it will work for sum of 3 functions also, that you should argue. So what's the derivative of a naught? 0. So that goes away. What's the derivative of this?
a1.
a1, very good. Plus what's the derivative of this?
2a2.
Okay. I should have probably, I think it should be obvious. I'm using something. So I'm using the following rule also. Okay. I should have told you this, that the derivative of a constant times f of x is equal to the constant times the derivative of f of x. Is this obvious? Right, just from the limit you can see. F of x, if it has a constant in there, the constant comes out of the limit. So this is obvious. That's what I am using here. Okay, so for this, a1 just comes out and the derivative of x is 1. For this, a2 comes out and the derivative of this is 2x. What will be the derivative of this? N a n x to the n minus 1. Is that okay? Any mistake? Okay, good. So let's, okay, that's one example. Okay, this is enough. So I'll just erase this one. What happened? My constant struggles. Why it's not working, I don't understand. Okay, finally. Okay, so rule number 2. This is going to be very useful. If I am given a function f and another function g, and I make a product of the two, f times g, and I want to know what's the derivative of f times g. Okay, I'll give you a proof of this one. Or do you think it's difficult? Can you do it? Or shall I leave it as an exercise? Exercise? You can do it? No, I'll do it. Are you confident? Okay, let's do it. So a good idea will be this. While I am doing it, you do it yourself, and at the end we compare. Okay? That's a better strategy. So don't look at the board, you keep doing yours, I will do mine. So this is, by definition, limit h going to 0, f of x So now this entire thing is my function, so I should evaluate this entire thing at x plus h. So what should it be? Is this point clear? Okay, think of this as some new function a of x. So you want to know the derivative of a of x. So for that I should take a of x plus h. But what is a of x plus h? A of x plus h is wherever you have x, replace it by x plus h. And that is why f of x plus h times g of x plus h. This should be okay. Minus divided by oh my goodness. Divided by h. Okay. Now what? What's the next step? Off कर दिया? Is it on or? It's still working, right? Please switch, put it on silent. So, can you guess the next step? No? Are you able to guess the next step? You are confident now? See, you have to make a derivative, right? Okay, think this way. What are you after? You are after saying that if I know the derivative of f, it's f prime, derivative of g, it's g prime. I want to write the product, the derivative of the product in terms of the derivatives of f's and g's separately, right? So you should in some way create that derivative. Now can you guess what it should be? Goal is clear? I want the result to be in terms of f prime and g prime. So I have to make that f prime g prime appear here. Simple. So I take this f of x plus h g of x plus h. Okay. This term is here, minus f of x g of x. Okay, so those two terms are here. Now I will add and subtract a term. The same term will be added and subtracted, which means it's 0. I don't do anything. I don't change the expression. Now here, look at this. I have x plus f of x plus h. Then if I subtract f of x times g of x plus h, then I will be able to take g of x plus h common, and you will have f of x plus h minus fx. That's what since I have subtracted this, I should add this back so that I don't change the value of the numerator. Okay, divided by h. So instead of writing over 1 over h, I will just write 1 over h. It's easier. It saves some space. Agreed? Okay. This is equal to limit h going to 0, 1 over h. Okay. Let's take g x plus h common. So it gives you f of x plus h minus f of x. Let's put a curly bracket times g of x plus h plus, now take f of x common. In these two you see f of x is common. So you get g of x plus h minus g of x. And my misery is back. Agreed? Okay, if you agree, then can you see what's going to happen next? See, this piece goes to 0 as x goes to 0, because this one becomes f of x. So f of x minus f of x. So that goes to 0. That always happens, right? That also goes to 0. But then the limit is not 0, because you have h also going to 0. So it's 0 over 0. So you have to find out what it is. So this is, again I am using the rules for limits. Okay, meaning if you have product of several pieces, you can take their limits if the limits are well defined. So a times a of x, b of x, if you take the limit x goes to x naught of this, it's the limit of ax naught, a of x, times the limit of b of x, right? You know this or not? So that's what I'm going to use. So it is, but this one separately I cannot do, right? Because I cannot just take limit of 1 over h. If you have a question, you should ask.
This is not symmetric in f and g.
H will go to 0.
Nice. I like the way you are thinking.
True, but h, limit h tends to 0, no? So it
Mm,
becomes,
very good.
Oh, okay.
But still,
it will not be symmetric.
It has to be.
Because we have added and subtracted a term, no? Same term.
Hmm.
Then it cannot be symmetric, no? Because we have added.
But at the end.
yeah, so you can add in, yeah, something you have put by hand, which is following the symmetry.
Exactly.
Okay, very good. But still I like your thinking. I like it. But your final result has to be symmetric. Okay? And you are going to see that symmetry. So what he is saying is, you are looking at the derivative of f times g. Whether it is f times t or g times f, it should be the same result. So the intermediate steps should look symmetric, and it does not look very symmetric under the interchange of f and g, because if I replace f by g here, you will get this piece.
Yes, everywhere it's fine except.
Except these.
Yeah,
Yes.
except there.
But you'll see in a moment that that is also fine. But good, very good thinking. So I will do. Can I do this? Can I take limit of 1 over h times limit of this times limit of that? No, it makes no sense. Because limit of this is not defined separately. Right? You understand? But limit h going to 0. So I'm first looking at this term. Okay. Limit of sums is sum of limits. So this I will do separately, that I will do separately. So first look at this one. So it is f of x plus h minus f of x 1 over, or let me just put it here. Okay, that 1 over h I have put here. That is this times limit h goes to 0 agreed? Up to here, is this fine? Do you agree? Plus, okay, limit h goes to 0, 1 over h f of x times this. So let me just write down first. See, f of x, it has no h in it. So as far as the variable h is concerned, that's a constant function. Is this point clear? Okay, since there is no h, it is a constant, it comes out of the limit, so it is f of x times limit h goes to 0 g of x plus h minus g of x over h. Okay, see whether we agree with this. Agreed? Good. What is this? That's f prime. Or let me just write d over dx f of x. What is that? It becomes, as h goes to 0, it becomes g of x. What is that? F of x. And what is that? D over dx of dx. Now it's symmetric. That's what you wanted. Is that okay? So this is called product rule or Leibniz rule. So we have now two results here. Let me write it down. Go. Let me write it down neatly. So we have shown that. So rule number 1 was d over dx, the first rule which I wrote. Or maybe instead of writing that much of f, I will just I'll just write this. Yeah, sorry, I was distracted, so I'll write the full thing here. Rule number 2, which I showed you just now, I proved, is if you take the derivative of the product of two functions, then what did we get? We got, take the derivative of the first function and multiply the second function. So d over dx f of x times g of x, okay, no derivative on g, plus leave the first function as it is and take the derivative of second function. That is what we have proved just now. Okay? And if you understand what I have, if you understand the steps that I have taken, then it will be not very difficult to show the following. Rule number 3. Okay, this is, I am leaving you as a homework. You should be able to do this. Now make this quotient. Take fx over g of x. And I will check next time whether you have done this. It will give you some practice with taking limits. Okay, so it's a useful thing to do. Show that you get the following. it's just like, so it has two parts. It has a numerator, okay, you can look here. It has a numerator and a denominator, the final result. In the numerator you have exactly this product rule but with a minus sign here. Okay, so you have d over dx f of x times g of x minus f of x times, okay, it keeps moving, and in the denominator you have g of x squared. Okay, prove this. I will write the same rules a little in a little less heavy way. It might be useful, it might be easier to remember them in this way. So rule 1 is, if you have function f and you have another function g, prime is f prime plus g prime. Okay, less clutter. If you have f times g and you take the derivative of this, it's f prime g plus f g prime. If you have f over g and you take the derivative, then it is f prime g minus f g prime over g square. Okay? Okay, good. Let's use this rule to find one nice result. Let's take g also be to equal f. Let's take g also same as f. So it is f times f, it's f square. Derivative of f square will be f prime into f plus f into f prime. F prime f plus f prime, but f prime is f prime f. So it is 2f prime. So what do you get? F prime f squared prime, meaning derivative of f square is 2f f prime. Agreed? So let's test. We have already seen that the derivative of x is equal to 1, right? That we have learned already. Why it's okay, anyway. Now let's find out d over dx of x squared, that you have learned to be 2x n into x power n minus 1. Now let's not use that result, rather use this result. So what is derivative of x square? It is 2 f is x. What's x prime? Derivative of x prime, it's 1. Same as what you had earlier. Okay? Good. So now you will be able to solve some of these. So now you can do some problems from your favorite book. Make your own problems. Okay? So we will stop here, and then in the next one, in the next lecture, we will start looking at the derivatives of trigonometric functions. Okay, and that will be very useful. And once we have started taking derivatives of trigonometric functions, we can go back to our hills and valleys. Okay, finding out the right place to take rest. Okay, we stop here.